I recorded today's lecture. Lecture is a little bit long. And if you see the Stanford textbook, I collected 3 chapters together for today. Probably you need to take 1 more week to review this. And after that, I will show to you short hands-on exercises. All right. So let's, I'm going to record this lecture and let you do this kind of, I'm going to quick point out to you guys so that you can take time and review the lecture. Oh, wait a minute. What happens?
Maybe next week or sooner.
Okay.
From database. But rather, we say data mining is a combination of all of those.
Oh, because of this.
So data mining is the area of interdisciplinary. Maybe
All right.
SEAL members.
So
those 3
something that I want you to.
We got 2 numbers within that range. Let's say 5 and 11.
Yeah, something that I can point to you.
Frequencies, more efficiently, more effectively. Mean, median, modes are
right. Some of the statistical
data sets,
measurement I explained it. This could be learned from any statistics course. But one thing that I want you to know, the so-called quantile, percentile or quartiles, so interquartile ranges from Q0 to Q3. So we divide it into 4 parts. So it is so-called box plot. If you see some of the statistical summary, particularly for financial stock price, then you may be able to see this kind of box plot. All right. So this slide explains to you some of those. So actually, mean, variance, standard deviations, those are very basic things that you need to know. Before we get to this Jakarta distance or similarity, let's see. I think did I explain somewhere
rather than mean
distance functions?
All those issues are data may be continuous, a combination of all.
Maybe a little later. For Jakarta distance or similarity,
one document, Y1 and Y2 subject.
Yeah. Before we get to the Jakarta, we all know Euclidean distance, right? I want you to think of, for example, geographical 2 locations. Then we have latitude and longitude, to the coordinate. Geocode may be given, so that we can measure the distance between the 2 points. For example, the Grand Central Terminal and Dobbs Ferry campus. Then we have 2 geo points, so that we can measure the distance. That distance is the length of the line that connects directly between the 2 data points. That is so-called the Euclidean distance. before we get the Euclidean distance, there is a Manhattan distance. What that means, if you're thinking of this is Manhattan distance, or in other words, it is called a city distance. This is, yeah. So if you think of the Manhattan city, and then there is a two corner, the measurement of those two corners, it can be measured, the length, the line that connects directly between two points, but it doesn't help us, right? If we want to see the distance between 2 points, one point you stand and the other points where your friends stand. So you want to measure how long does it take. Then actually you have to measure the avenue distance and then street distance. You need to add them all. That is this, okay? So that's that kind of things what actually we would practice using Python and all a little after this slide. This is the Chebyshev distance. And then this is a Jacquard distance. Jacquard distance is not just the distance between two geographical location, but I want you to think of two sets of data. Let's say the libraries of Dobbs-Ferry campus and libraries in Manhattan campus. Can you see the similarity or distance between two library sets? So each library has a collection of books and journals, some of the periodicals, right? So how can we compare two sets? Then we can consider Jacquard distance. The distance between sets cannot be measured by the distance that we used to measure for two geo points. So we will look at the set. So Jacquard distance, so given to distance of C1 and C2 is nothing but the complement of the union of two sets over this is an intersect, right? Intersection of two sets over union of two sets. Okay, that is the distance when it comes to two sets of data. So there's some practical examples that you can follow. So I explained that. And also given two documents, okay? So document 5 and document 6, actually there are, in this example, more than that. I think we have 6 documents, right? It's document doc 1, 2, 3, 4, 5, 6. So how can we measure the given two documents? Then documents is a collection of the words, okay? So we say document 5 is a set of the words. Well, we can also consider the occurrence of that word. More often, if there is a higher frequency of words in a specific documents, then we can simply say, hey, that document is talking about that high frequency the keywords. By the way, in this case, we should remove all the stop words. We consider only the keywords. Not like this. This is a simple the coding examples, but therefore we have 2 A is this kind of meaningless words needs to be removed, and only something meaningful words, so-called keywords, will be collected, and then we count the frequency of those. That represents one document. So another set of the keywords and frequency, that the dictionary type of data can represent another document. So we consider after that, we can see the distance between the two documents or three documents or whatever the documents, okay? When it comes to sets. So we started with the two data points, geographical data points. So we can measure the distance. And now we can measure the two sets of data like a documents or a book. So finding similar documents. Okay. From this point toward the end of this presentation is about the K-shingle or K-gram approach. So it defines the shingles, why we have this kind of new idea. This idea, all the theories that I am presenting right now, written in that Stanford textbook. So those who purchased that Stanford textbook may be able to find out this. But I summarized some of those here. So in this case, how can we compare very large data sets? How can we minimize? How can we get the hashing? And therefore, we can get the min hashing. That's explained. And this is very similar to Jacques-Hardy, right? Similar things can be discussed. So let's say we have 4 documents like this, and then shingles. Shingles is not just one single keywords, but some of the combinations. Not just AI, artificial intelligence, but what if open AI? Then it's more specific, right? Or not just the chat, but if we say chat GPT, one word, that may be shingle, right? So more meaningful phrase, clause, that'll be a shingles. So we have a matrix like this, where there is a 1 means this document, first document contains this shingle, that shingle, but no other shingles. 0 means none exist. 1 means that exists. So 0, 0, 0, 1, 0, something like this. In this case, only we talk about Boolean matrix. What that means here, we don't really consider yet the frequency, but existence. Whether it exists, then we put number 1. If it doesn't exist, then 0. Of course, we can extend this to, for example, number 5, then that appears 5 times. 99, then the particular shingles appears 99 times, something like that. But this simple concept started with the Boolean matrix. And then we have hash functions. Given 2 hash functions, eventually we will have there's a lot of steps that you follow. So finally, maybe something like this. So given this multiple rows and documents, then we can minimize these documents like this. So 0 means it doesn't exist. 1 means the magnitude, some of the magnitude. So this, if we have, for example, the Boolean matrix that represents entire library, then what is the size of this? How many rows? Maybe billion rows, right? How can it handle that billion rows in our computations? So the idea here is that, hey, we want to minimize this matrix, like this mean hashing. That is the whole idea of this the chapter. Details, you can find it from a textbook, but you don't need to, but textbook shows a little deeper than this slide. So we look, this slide try to explain with the examples. Okay, so I wanted to follow this slide and my recording. This may be enough for you. So all these details, I'll leave this on to you, so you can take time to review this. This slide, this explanation, YouTube slide, it's almost 2-hour explanations. So I wanted to do that. Meanwhile, hands-on, okay? So we will look at the hands-on. The idea of this, we want to generate two-dimensional number matrix. For example, like this, I imported pandas and NumPy for statistical number in Python, and panda is more like data structures. And this panda has a class called the data frame. I want to populate this data frame from a random number generation. Okay, so random number can be generated from NumPy here, NP. So np.random.rand in integer. So I want to populate integer data. Integer can be generated between 0 and 100. How many size integers, random numbers, random integers? 106. What that means is that 100 rows and 6 columns. 100 rows and 6 columns. And column names, I listed here MCBER, but I wanted to get yours your last name, okay? So it could be, for example, instead of this, my case, so I would have, my last name is Yoon, Y-O-O-N, but let's assume there is no duplication, okay? Then Y-O-N. If I have 3, then this should be 3. So I would say here, columns consist of your last name, consists of Columns consist of distinctive characters of your last name. Okay. So if you execute this, then it'll be because I didn't. I should execute on highlighted. Oh, did I lose? I think I lose some. Okay. So this is highlighted. I need to hold down Option key and hit enter. Right. So I have Y, column name Y, O, and then values generated, right? If somebody has the longer name, let's say A, B, C, D, E, F, G, H, I, J, K, how many characters? 2, 4, 6, 8, 10, 11. Then you need to do here 11 and hit enter. Then we have the column name A through K, right, from 0 to 99, which is that many. What I want to do is I want to save this. Okay, so save this. And then file name here, mandist.xlsx. I want to save this in Excel file. Okay. So you guys have done that. So I'm going to save that. Save it, and it'll be. I'm going to bring that. Okay, this is something that I got. All right. And then forget about this. And then I want to make a Manhattan distance. The way that I want to get Manhattan distance, here, df, by the way, df I log, then I want to, the df is the entire this matrix. If I want to point out some cell by index, then I need to say df dot I log and index 1 and column 2. Then it'll be 58. So index 1 here, starting from 0. Column 2, starting from 0, then 1, 0, 1, 2. So 58. That returns. I can get also df dot just log location. Then you need to do that row number, say 1. And then you can say, I want to get C, the column name C. Then it'll return this 58. The same 58 can be pointed by the location label. So label here, that label, the row labels are given, right? Starting from 0. So we use that row label. Row labels remains the same in this case, whether we want to use the index location or simply the location. And for this location, we need to get the label of the columns. So I use this C. Okay, that's what we have instead of the index number 2. So this is handy if I can get, for example, K, then it'll return 22, this 22, K number 22. So back here, we want to compute the Manhattan distance. Manhattan distance, as we looked at a minute ago. So Euclidean distance and Manhattan distance. Manhattan distance simply measure the vertically how many avenues and how many streets, how many avenues horizontally, if you think of the Manhattan city, and how many the vertically, how many streets vertically, how many streets do you need to walk, how many avenues do you need to walk. That is the number of the measurement. That is Manhattan distance. So we simply measure for each row. I want to measure second column and fourth column. First and second. Second column, this is a column values, right? This is the first column and second column. Second column and this is a row number. Row number continues from 0 to 99. At each row, I want to pick the columns. So second column and fifth column, second column, third, fourth, fifth. So 86 and 79. I measure that. The idea here is 86 and 64, this is the location, corner location where I am. Second and third and fourth. And 15, 6, that is the corner location of my friends are currently waiting. So I want to measure the distance at Manhattan. These two location, 86 and 64 and 79 and 17. That's what I have here. This is X coordinates of 2 points, 1 and 4th, and Y coordinates of 2 points, 2 and 5. And then I need to get also absolute. If we have subtract, then ironically, sometimes I have a big number minus and small number, or small number minus big number, then distance may be negative. But actually there is no such distance, right? So I want to make this to absolute value. So no matter, I want to ignore the sign. Only I want to know is magnitude of the distance. So I put abstract of the first subtraction and abstract of the second subtraction. What that means is that I'm in the corner of one location and my friend is another location. Then I want to measure how many avenues. So how many avenues? That is this. And then how many streets? And I add them. That is Manhattan distance. I want measure Manhattan distance and attach that to a specific column number. So in this case, if I have 11, then column number right now 10. So I need to have 11 here, right? In this case, if I have ABCD that way. So I want to insert that new column, and I want to call that Manhattan distance. I save it. So I save it. So up to this point, I can run. Then I will have this, right? So Manhattan distance. If you want to make manual Manhattan distance, so I want to put here my column. I would say check, my manual check, the distance here. Then that is absolute distance, absolute value of here 1 and 4, right? 0, 1. 1 minus 0, 1, 2, 3, 4. That absolute value plus that is how many avenues. Another absolute value. How many street? So this guy minus that guy and hit enter. From my Python, distance, Manhattan distance 13. My manual, it also 13. So I could compute that all the way to the end. Then it's automatically, right? So if you see any of those two, they are correct. My check is correct, of course, right? This computation is by Excel. This computation is by Python, right? You can do this not only Manhattan distance, but Euclidean distance. I wanted to recall 2 points in XY coordinates. Then how can you measure the distance between the 2 points? That is a Euclidean distance. That has been studied in your early algebra course, right? And also the formula explained on slide and also video lecture. So I wanted to follow that. I wanted to do this, a little bit of this, a little bit more further than this for your next homework assignments. This is Python. Okay, I do not want to save this. Okay. Oh yeah, let's do a little further. Okay, yeah, this is that. Okay, and then so Python can save generates the data, random number data, and then Manhattan distance computed and save it Excel files. Okay. And then I want to practice similar things in R. In R, what we want to do is to read that Excel file that we generated. Here, there is Excel file, right? Man, that 533, just about 30 minutes ago, it was generated. And then we want to read that file. Here, man dist.xlsx. In order to read Excel files, you need to the import library in R. In R, the library means why? This is nothing but import. Import a read Excel module. So module can be imported. We have dot here. This is automatically generated dot. Makes sense. Oops. So okay. If you do not have a real X, I want you to have install packages and Excel XX or real Excel. In this case, real Excel. If read the Excel, install it. How can you install? You can do install dot packages and then read Excel. Okay, if you want to use Excel SX, then you could do like this. But anyway, as far as there is a read Excel, then we can read it. This is a path expression. And read underscore Excel XX, that comes from this read Excel. I want to read, oh, no, that's from this. So read underscore Excel. I want to read the Excel files from that path. Path where there is the man dist Excel files. And I want to populate that data into data frame. Okay. And in the data frame, so I want to say that TF. Data frame, I want to order the data frame based upon Manhattan column. I want to sort based upon Manhattan column. Column called the Manhattan. Why we have here comma? So DF, by the way, if we read this, let's read this much. Okay, then if we have a DF and Manhattan, then DF $, then we will have a Manhattan here. Manhattan, comma, and I want to see only one the row number 1 to 5. Only that many. Oops, why we have that many? Oh, 1, 2, 3, 4, 5. Oh, this is a column. Oh, Manhattan column. It should be, I think it should be like this. TF 1 through 5 and 1 through 2. Yeah. We can, this TF can be data frame in all can be accessed by TF column index, row index column, row index first, row index comma that, or you can do df dot that data frame name. So we can say df dollar and column. Yeah, column. Yeah. So if we have a df and df dollar a, df dollar c, then we have undefined column selected. Okay. Actually, this is everything, right? So df comma, then it gives us everything. So df 1 and 1, 1, then it gives us this 1 and 1 here. So df one and df c, that's column not selected. Yeah. I think, let's see. Let's do like this. Yeah, selected by row index and column index. But in this case, we order based upon Manhattan, and we call that TF sorted, and we want to print it. So given this TF, this Manhattan distance is not really solid, right? If you see this, it is not solid. But if you run this up to this print, then actually it is a solid, right? Yeah, smallest distance is 10 blocks and 12 blocks. And then 43 blocks and 63 blocks, something like that. And 94 blocks. And then finally, we want to write it back to our file. We call that man dist solid. This is a different file name. That's a location. And then we use the function write underscore XLSX. Very similar to when we read, we use this function, read underscore XL. Here we want to read underscore XLSX. So extension is XLSX. What I want to save this DF solid, just that we looked at. This will be written on this file, and column name and format headers remains the same. This is the code, our code. So if you run this, let's save this. I want to run everything. Okay. Then I have here man dist solid, just created. So this is originally written from Python code. How can we show this big? How can I make this bigger? No. View. Zoom. Let me see here. Mac OS, how to no. All right, never mind. Okay, the sorted ones here. Oh, here. Yeah, this one is a solid, right? Man dist solid, that is saved here. Man dist solid, and from your Python, man dist Excel, that is this file. Okay, so this is a simple exercise that you can handle using Python, R, and Excel. Right, Excel, you could do many manually, only manually, therefore, anyone can do very easily. But if we have very many rows, here, then almost impossible to handle it, right? For example, here, let's say I want to have not only 100 rows, let's say it's 1 million rows. This guy cannot make 1 million rows, right? Maximum, I think 1 million. So maybe 900,000 rows. Let's say if this works. So I want to delete this, right? Don't save. And if I want to rerun this, and where is, yeah, that is again generated. Excel cannot open the file because the file format extension cannot be valid. Why it is not valid? I want to remove this and do this one more time. Not sure. Oh, is it too big? This must be too big. Let's say 100,000. I think it should work. Still it doesn't finish. Oh, here. Length of a value does not match the length of index. Oh, somewhere here. Oh, this guy. Oh, yeah. So let's go back. 900,000. So 900,000. Others, I think it should remain the same. And let's try. I think writing has some issue. 0 bytes. Doesn't finish. Let's wait. What happens? The Python, the value generation has no problem, but writing, it has been generated here, right? As you looked at here. But writing back, that takes long. So creating Excel files. So let's see. Okay. Where is this going right now? Oh, another printer TF. What is this? A, B, C, D, K, C, D, F. Oh, this guy is talking about this, maybe. And then trying to do this. Oh, here. K and Manhattan. That's generated. Why it takes so long? 1 million data takes so long. And then writing maybe. Takes forever. So big data needs big power. Okay. Done. What about file? File hasn't been cleared yet. Can I open? Oh, it can be opened. Oh, 51 megabyte. Come on. So how many? No, this is not. Oh, this is sorted. I'm talking about this. Okay, here. This is a sorted. How many rows? Wow. 900,000 rows. So if you want to check, then similarly, you need to check, right? Check, then you need to do ABS and 2, 3, 4, 5, -5, ABS minus this, and hit enter. So that is, so we need to do this all the way. How can you get this all the way down so that you can copy the formula, right? I think it takes, again, forever. Even if you do manually, it looks great. But if you do this in Python, you can make it quick, but I want to scroll this down. Only right now, 8,000 or 9,000. And 10,000, it may go forever. If I release my mouse, it will calculate up to here, right? It takes forever, like this. I do only this. But anyway, the point that I try to show to you, you can manipulate the data, bring in Excel applications. If the data size is small, then we'll be okay. But if you have a big data, then almost impossible to handle it in Excel as we just tried. But if you do code, at least Python or R can handle very quickly. Only the issue there, if you want to save it back to Excel, Excel is another a proprietary application software, then it may take a little while. Other than that, only the codings, it works fast. Okay. So what we have done today, we practiced a little bit of a using statistical or small computation to measure the similarities. Similarity is the very foundation measurement when you do mining. For example, if you want to classify some of the objects, how can you classify? You can classify them based upon their similarity, right? If they are similar, then you can put them in one group. Same thing with clustering. That is a data mining, the first step in data mining. If you look at, if anyone has any experience in ChatGPT, then underlying the measurement for ChatGPT is the similarities. ChatGPT already knows some answer to your question. Then GPT wants to find the best answer from the pool that GPT has. Then the most similar answer needs to be given to you. So similarity is one of foundation tools that you can expose data mining. There are two types of similarities. Alphanumeric similarities, similarities in alphanumeric data, or similarities of data sets. Typical data sets are library data sets or documents. If it's a library or documents, then you need to handle based upon set theory. If that is an alphanumerical, then you can simply compute like we did. All right. Any question? Ryan, Alex, Nancy, Justin. How are you guys?
Professor, can you hear us now?
Good.
All right.
You can
Any
hear
questions?
us? Can you hear us?
Yes.
Ah,
Hi, Ryan.
was that was a good question, right?
Yeah.
Yeah.
All right.
Yeah, Professor, I was trying to tell you in the beginning, I don't think you heard us at the time. So the numbers, remember you asked me about the numbers app? About putting the data instead of on Excel, but instead of Excel into the numbers app, which is the Apple version of Excel.
Okay.
So it
in
actually
Python?
doesn't allow you to do that on Apple because it's an app. So it's considered that basically Python can't create or modify anything that's inside your app. So basically, yeah, that
right.
doesn't function.
Python can modify the Excel data in Excel application.
Yes, but not in
using-
numbers. I checked because you asked me to let you know after I check.
Oh, okay. Oh, you did?
Yes, yes,
Oh,
and I wrote it in the comments as well.
Oh, is that right? Oh, there's no chat. Let's try to see. Oh, I don't get any.
Okay,
All right.
I'll submit
I
it in
appreciate
the,
it. I appreciate it, Alex.
Of course, yeah.
Yeah.
It was I was just curious myself, so but now I know at least.
Oh, yeah, great. So, right, Python can handle Excel, and Excel. No, Excel doesn't handle Python code. Yeah, code can handle application program because the application program is developed using some of the language, maybe Python or R. Basically, it may be written in some other languages, but in general, right, language can touch some of the application software. That's what we try to do. Any other comments, question? All right, if you do not, then as I posted, the next 2 weeks, we do not have the synchronous meetings like this time. You don't need to keep this time. So we'll meet 3 weeks from today, this time at 5 o'clock. But we'll continue to, the class will go continually. So I will post the course materials and some of the recordings as you can follow. Something that you guys need to do after these similarities, I think next topic that you guys need to do is, I think that is a priori algorithm, so-called supermarkets basket data mining, which is very, very typical data mining example. It was exemplified by IBM guys, IBM Almaden Center in California, early 1990. They looked at the supermarket baskets, and looking at the baskets, and they are all in one basket, all different items. Then items in one basket is nothing but association of those items. Milk and egg, orange juice, they are somehow associated. And then that may be related with the shopper. If a shopper is young couple or young single or old couple, all different range of the customers might have different sets of basket item sets in a shopping basket. So looking at that shopping basket, we may be able to see a type of this shoppers may want to buy this kind of items. That was first studied about 30 years ago. Now it is very common. If you go to Amazon.com, then always they never forget to tell you that those who pick this item, just like you, are highly likely consider this kind of another kinds of the items. So they want to promote their sales, right? So that's basically come from that association rules. So one pattern, one shopping patterns can associate with another type of shoppings. That type of the mathematically formulated and computed in computer, like codings. So we'll look at that next week. That is the aggregation rules or a priori data mining rules, followed by two big issues: classification and clusterings. Classification and clusterings. All right, so those are coming. So next 2 weeks, you guys look at only theory, no hands-on for a while. And then in 3 weeks, we'll come back. When we come back, then we will see some of the hands-on labs and experience. All right. All right, I'll stop here. So
just one quick question before you stop. So since we're going to be looking at theory in the next 2 weeks, are we going to have homework on that theory, or are we going to wait to go?
Yeah, we'll have some of the homework. That requires a paper and pencil.
Oh, okay.
If it is a theory, then paper, pencil. If there's a hands-on, then you guys homework also hands-on homeworks.
Okay, sounds good. Thank you.
All right. All right. Have a good night, everyone. See you later. Virtually next week.
Yeah.
Have a good night.
Okay, have a good one.
Good night.
Good night, Professor. Thank you.